Welcome to the Software People Stories. I'm Shiv.
I'm Chitra.
And I'm Gayatri.
We bring you interesting, untold stories of people
Associated with the creation
Or consumption of software-based solutions.
You'll hear stories of what worked,
and sometimes what didn't,
you will also hear very personal experiences.
and insights that would trigger your thoughts
And inspire you to do even greater things.
In this episode, I'm in conversation with Baktha Muralidharan, AVP, Unified Communications at Sompo International. He shares how his first job to develop electronic solutions for use in the Indian Navy for data collection increased his appreciation and attraction to work in software that he got an exposure to towards the end of his undergrad course. After masters, getting an opportunity to work on Ethernet that was just becoming more widely adopted. And he continues to talk about the various things that he did as technologies were emerging, such as the client-server approaches, or in terms of networking, the SNMP, or the Simple Network Management Protocol. Moving to companies to loose end when AT&T was split up, and working on what's called as the management information base for knobs that could be manipulated to change the behavior of networks. And then on to Cisco, when the company was acquired, and preferring to work more with technology and interfacing with people, read it as customers, and so taking up roles in service over software development. And he also mentions why one needs appropriate technology and not necessarily the latest technology when IT is an enabler for the core business. I asked him a question about how comfortable it was working with customers and supporting them, and the answer to that question and some more interesting pieces of information from his experience will be in the second episode. Listen on. Hi, Murali. Welcome to the Software People Stories.
Glad to be here, Shiv.
Like we always do, I would like to start with your own self-introduction. You can talk about your origin story and your career trajectory, and we can take it from there.
Surely. So, you know about me. We went to school together. After graduating from undergraduate in 1980, I went to work in Bombay for Tata Electric Company R&D. So they had a small R&D division, which it was an electric company, but the R&D division did something. In those days, this is going back, of course, 40 years ago, Intel had just introduced this 8080 chip, if you recall. Pretty basic and interesting architecture. And so they were developing electronics for use and piloting with the Indian Navy in those days, right? And one of the things that they had going at the time when I joined them in 1980 was they were doing some sort of data collection from a couple of different sensors. So they were all serial interfaces. And Intel 8080 had, there was a serial interface module, a card, chip, I should say. This used to collect data periodically. And in terms of, and we used to get deposited, right, on off-board secondary storage. In those days, in terms of analytics, nothing significant was being done. But all the same, the opportunity to work in a microprocessor environment, doing software at a fairly low level was quite exciting. And I should say that, as you know, Shiv, we studied electrical and communications engineering, right? That was our major, ECE, wherein we had a mixture of electronics and information theory, error correction codes, and even some radio electronics. We learned a lot of that. But towards the end of our undergraduate program, if you remember, sort of software sort of started to take off. It was appealing to a lot of us, right? For reasons that's still not very clear to me, because I think looking back, hardware could be just as exciting, but all the same, I was drawn, bitten by the software bug and wanted to transition after having I remember even in my bachelor's, the project was to build some sort of a timer using those days SSI integration chips, right? Small scale, probably 10 transistors in a chip. So we did all that, but ended up leaning towards software industry. And the job opportunities also were opening up more for software in India at the time, anyhow. So I went and worked for them for roughly a year. Pretty exciting, a lot of stuff to learn. Did coding in macro and stuff like that. But I did want to get a shot at doing postgraduate studies. Mm-hmm. So I had applied even as we graduating, and a bit too late, so I wasn't getting admissions at the time. So I went back and took the GRE again and applied again, and was lucky enough to get into school in the Boston area, Northeastern University. And also, if you remember, in those days, getting a student visa was somewhat iffy, and I remember getting rejected in Madras. So then I appeared in Bombay, got the visa, and came over to Northeastern University. This is a master's program in very similar type of major, electronics and communications. It was a little bit more into computer engineering, less so on radio electronics, right? Okay. Microwaves and things of that nature. So it further kind of prepared me to go more into the software industry. And so as you remember, when we were in college, there is software in the form of academic courses was not extensive. There was probably one or two here and there. I remember doing some Fortran. We had just obtained DEC 10 system, and it was quite exciting. And prior to that, I don't remember, was there an IBM system with the card reader and everything? So the DEC 10 system, we had just literally the last year of our college, we had it. It's quite exciting. So digital was a big name in our minds. And so the attraction and appeal towards software, of course, intensified. In my graduate school, you had a choice between doing a project versus doing a couple of elective courses to graduate. And I ended up doing a project. Looking back, it was quite a simple, but exciting back then, nevertheless, a simple project of programming a robot to move a small object from one coordinate x1, y1, z1 to another coordinate x2, y2, z2. That's a pretty trivial task, but it was pretty exciting. It was we had obtained a small robot. Trying to remember the maker of the robot. I'll get it in a minute. So anyway, so we got that, and when we got it, it was only capable of very low, it's called like a microcode, right? Not even at a macro level. So we had to write a compiler for the macro so you could then write somewhat higher level program. For every little thing, you didn't have to write 25 microcode instructions. Did that, quite exciting. And the other thing that we did, if you remember, right around 1980 was when Ethernet was invented, right? By three companies, Digital Equipment Corporation, Intel, and Xerox. They were the three pioneers, and they invented. And we in the lab, I got an assistantship. By the way, I should mention, when I first got admission, I didn't get a scholarship. And my uncle was in Boston then. So he funded my first semester. Nice of him to write a check for $6,000. So I came here with no scholarship. My father borrowed money to put me on the plane. In those days, it was 7 rupees for US dollar. It's a nice thing to capture, right? Remember. But 2 months into the program, I was fortunate that I got an assistantship in the computer lab of a professor there, right? So he was to write some programs, which I did. And they paid a decent sum of money, which was enough for me to pay my tuition as well as take care of myself. So quite lucky. So very happy about that. So in the lab, one of the things we tried was normally, right, Ethernet has some algorithms. It's called collision detection, CDMA. So collision, what it means is when multiple systems are connected to the Ethernet, think of it as a linear wire. Obviously, when one computer injects traffic into the wire, another could, right, purely by chance, by randomly. So then you would cause what's called a collision, in which case the pulses that you put out are not intelligible. Then you would back off. And if you back off by the same amount and come back, you're going to collide again. So then how do you resolve it? So there is an algorithm called CDMA, and then collision detection, and it was a random back off. So you back off by a random amount of time and come back. That increases the chance of you're securing the line before you inject traffic into it. So we had, in those days, I'm sure you remember, right? There's copper telephone wire through the walls in all the the rooms in all the buildings. So you plug your telephone, two-wire telephone into that socket. It's called an RJ11 connector, and we used that and connected it to our serial interface on the computer, and tried to create an Ethernet using existing wiring in the building, rather than tearing apart the walls to create, put new Ethernet coaxial cable and Cat5 and 6. None of that existed there in 1981. So we were able to actually communicate between many computers in the lab. So that was really exciting. It's not something that we did originally. It was, the technology was already out. We just we tested it with copper wire that was already in the building, that was used for telephone wire, and we were able to do it. So that was quite exciting. But that also got me a job in digital.
I remember learning, and then it was pretty exciting when I heard the term saying null modem.
Yeah, exactly. That's right. Those are the days of null modem. Do you know the speed? Ridiculous, 256 kilobit per second, something like that. Even 256 was advanced. I think US robotics, there are modems for 64 kilobit per second, right? Which is, I don't even know, how we communicated in those days. But nevertheless, that was the prevailing speed. So fortunately, I got a job in the campus interview with the digital after I graduated. And they had something similar, low-cost Ethernet card for computers that day. Digital was doing a few PCs. I remember ORG Systems used to be Digital's partner, right, in around the world, particularly in India. And this was even at one time, worked with a few engineers that were in the US from ORG. So that sort of was my introduction, or my entry into communications part of digital communication, discrete communications part of the software industry, if you like, as opposed to other software is a very vast field. And this is something that is maybe because we learned some communications information theory from in school. This is a bit appealing to me and attractive to me. And this is an opportunity to work in software, in computers, but do something in communications, right? It was also the time, if you remember, Bolt, Beranek, and Newman, the ARPANET was just introduced. Started to make it big. They did emails and stuff like that. So it was somewhat of a bleeding edge in the computer end. So it sort of felt good to be associated with it. And I should mention, it also paved the way for them sponsoring my permanent residence. So why not? So that was a good. Stayed with them. I worked on after that in an area called. Those days were also, if you remember, we moved away. Interesting, computer industry, we go back and forth, right? Every 10 years so in those days, we moved away from centralized computing to distributed computing, right? So IBM used to have all this centralized computing, the terminals are dumb, and then distributed computing started within many computers, and Banyan Networks, Digital Network Computer Equipment Corporation. And so they had this client server technology architecture was developing, right? So a good amount of intelligence remained in the server end, but some amount of intelligence and capability shifted to the client, thereby maximizing or optimizing the use of these servers. So if something could be done locally, it made sense, because this also, if you think about it, I think the youngsters may be interested to find, right? There's a constant intertwined history of computing and networking. The computers become a little too fast to inject traffic. The transmission was not quite up there. Then at one point, the transmission became very capable in terms of speed. The computer doesn't catch. Then computer is a little bit behind. They constantly do this back and forth game even today, right? So in a sense, if you think about it, the telephone wire only carried voice for almost 100 years since Alexander Graham Bell invented the company AT&T, thinking that you couldn't put faster traffic in it without getting distorted, right? You need optics. But later on, it was disproved with the DSL technologies that you could modulate. If you modulated with a fairly advanced modulator on your used robotics card, the same old damn copper line can now carry much faster speeds, right? And that goes on for quite a while until recently. Now we get now fiber to the curb, fiber to the home. But until recently, you could get quite fast, the telephone. So somewhat similar. So I worked on a print server whereby the clients would send print jobs, and the print server would then, print it. This client server technology was sort of was something that I had an opportunity to work on. Quite interesting. And as you know, what is it called? X11 came out of MIT, right? And Java, where the notion of doing a lot of computing locally on your computer to display and do things, or even handle some small levels of human user interface rather than burdening the server, right? That sort of took off. So worked on that, and I was the digital for almost 11 years. Then I had an opportunity to go work in Bell Labs for a few years, where they were developing this frame relay and ATM transmission technologies. So that was very interesting. At Digital, I was an employee, but in Bell Labs, I was a consulting role. I had an opportunity to work on network management. In those days, the IETF and IP-based networking was taking off, and the traditional OSI-based networking was sort of giving in for that. If you remember, a lot of the OSI standards are very big, CCITT, but IP sort of came from behind and, started becoming pervasive. And so went to work in AT&T. A lot of this frame relay and ATM technologies, frame relay for sure, right? CCITT standard, and the TCP/IP was taking off as a level 3 protocol. If you remember from the stack, the level 1, level 2, right? Yeah, transport. Yeah, exactly. IP at the internet level protocol, IP was replacing other protocol, including X25, but at the lower levels, the frame relay and ATM, you may roughly say it's a level 1.5 and level 2. That was a technology that's very interesting. The AT&T delivers service as a telephone company, but the service development happened in Bell Labs, right? Including the technology. So Bell Labs always develops technology, and then the parent company AT&T goes and deploys it across the country to monetize it. That was very exciting for me. I'm still doing software, but I was doing network management. It was interesting because prior to, at the time, if customers needed to subscribe to a circuit with a certain bandwidth, they can do so. But if they want to change the speed because their needs grew, their business grew, then this was a big deal. They had to create a work order. AT&T would then go through work in their control center, network operation center. It would be a major project. So the frame relay allowed for really cool technology whereby customer could go online and just change their characteristics of speed of their line in a matter of minutes. Much like if you think about AWS today, computing, if your needs grow, you get elastic computing. You don't even have to go. You just have to define your needs, and you just get a bill at the end of the month that for 2 days in the middle of the day, in the middle of the month, your compute needs went up, you used more memory, or your CPU, you get billed for it. How wonderful is that? In those days, it was painfully manual for transmission and circuit. The previous dedicated circuit, T1, as you remember, was a modulation technique, right? So in T1, it was 1.54 megabit per second. And if you needed a higher speed, you couldn't. You could then go to what's called a fractional T3, where you could put multiple T1s together. And all of that was a very manual and taking very long time. Almost fondly, I recall, I don't know about fondly, my father used to work for Indian telephones, and those days getting a telephone was like about a 2-year project. Almost silly to look back and think of those days back in India and in any part of the world for that matter. So that's how it was for transmission lines. This is the last mile in the customers, right? So the frame relay allowed customers to, on the fly, dynamically alter their pipe size, so to speak, and we implemented using what's called a network management. And the network management was using ISO OSI stack, I should say. And then in parallel on the side, this SNMP protocol came along, if you remember. And true to its name, it was much simpler. It's a simple network management protocol, right? I knew this was developing and it was growing in interest. So I learned SNMP, and it opened up a lot of job opportunities for me. So in frame-related network management, even I was fortunate to work with some pretty smart people in AT&T, and learned a lot. We implemented some it's called customer network management, as opposed to opening a ticket and having AT&T do all that. So I worked on that for some years. And then in 1993, if you remember, AT&T Mobile split 3 ways into Lucent Technologies, AT&T, and then something called NCR. We had to choose. I went and worked for Lucent Technologies in their wireless division, right? In those days, it was 2G. Now we are in 5G in wireless, right? So it's the second generation wireless. It was something called AMPS in the US. In Europe and India, it was a different technology. So it was fairly pervasive in the US. So I worked on it for some time, again, developing, defining, there's something called MIB, right? Management Information Base, that basically captures and models what about your system can be managed. When I say managed, includes monitoring, right? So any system, if you take from a management standpoint, there are some knobs you can tune, you can turn to change, and some things are one way. You read, it's a sensor output. It's a feedback control system. You read the sensors, figure out if it's performing optimally, and if it's not, you then alter something, right? Maybe gain something, So we call them control knobs. So the MIB management information base would capture all that in a hierarchical data structure. So we developed some MIBs for second generation wireless cell towers for Lucent Technologies, and implemented them also. So that was interesting. There's also right around then, C++ as an object-oriented software paradigm was starting to take off. One of my manager joined a startup company called Maxcom Technologies, which was using DSL technologies to provide multiple lines in a home. So normally when you have, in those days, in the 1990s, mid-90s, you may have 10 phones at home, one in the kitchen, one in the bedroom, but they're all same number, right? Same number, just different devices. The DSL technology that we developed allowed you to have different lines for the different endpoints in your house. So the bedroom line could be a different number from the number. I don't know how applicable it would be, and it was right around the time cell phone technology was taking off. So, but we are lucky that we got the startup got acquired by Cisco, and because they implemented the technology that Bellcore had defined to do this multiplexing of voice channels on a DSL line. So that was the attraction, and so they bought the company. We were 30 people. We joined Cisco Systems in 1998. But soon after that, Cisco just tore down the product and solution and just kept the people, as often has it, right? It's the people that they really like, and the technology itself evolves. And sure enough, the DSL technologies are faded away. And there used to be even in the US, and I'm sure in India too, Cisco made a lot of line cards that get, so normally, just to give some background, normally your telephone line is can go up to 1.8 miles, right, without any distortion. If you want to go beyond that, you would terminate it and then boost it and to send it on the, sometimes even digitize it, right? So these are called VDSL line cards. So they used to use the Cisco boxes in at the end of a block. If you have a development block community, they put one at the end of the community that basically is okay. It's not just a dumb repeater, but it also digitized it. So it was used for those technologies. Anyway, the telephone thing went away, cell phone took off, and you and your daughter and son, everybody could have different lines without a fear of anybody else picking up. So from a technology standpoint, by the way, but Cisco was very interesting. It was really in the IP world. Cisco was taking off as big routing and switching gear provider, right? They were not in software back then. So routing and switching were really well known and well deployed. They had routers for every customer base, right? So they made routers all the way from internet service provider routers all the way to a mom and pop shop, your dentist routing device. So I worked on a medium level, it's called 10,000 routers. And the router has a route engine, which used to be called Pizza Box. And the route engine had different functions from QoS to security to ACLs, access control, and device control. So there are a couple of they are called technology towers. So I worked on them for a few years. But in the meantime, it's interesting at this time. Until then, I was always somehow tried to work only in engineering, development, and tried to associate myself with bleeding edge, not primarily because it was exciting to me, and more because perhaps job opportunities, right? And as you know, especially in the US, Indians are known for their STEM, math, science capabilities, and so some of these technologies involved some smart programming and things. So it was very appealing from a job, and and also to me personally, I felt more comfortable being in the engineering corner of a company than I was not. I should say, working with people was not my strength. Okay, managing a team of people was not my strength, and something that I shied away from. But I did recognize that I liked working with people, not people within the company as employees, but people outside, customers, so to speak. So I was looking to migrate a transition to a service-oriented role, not software development. The other thing that led to my thinking, right, was it's all nice and great to work in cutting edge technology, but very often, if you leave the engineering domain, the common industry is well behind cutting edge technology. They are still using last generation technology, and that's something you have to contend with. And then to give an example, just to fast forward, I work in an insurance industry now, insurance company, financial services industry. Some of the technology is waiting at our doorstep to be deployed, but the people are not ready yet. And obviously, you are an enabler of the business. You are not the business, right? In a financial company, IT is only an enabler. So IT is only to make their work efficient, their collaboration efficient. It's not the mainstay. So anything you do, if it's going to cause confusion, if it's going to have a steep learning curve, that's discouraged against. And it's not a wise way to introduce technology also. That doesn't mean to say it's not going to happen. It's going to happen, but I'm recognizing that this passion to be in the cutting edge, to be in the bleeding edge, is okay if you work for the Microsofts and Cisco's and Google's. Okay, so that's where you develop them. But in terms of adoption, in terms of deployment, you'll find, depending on which part of the technology, they're not so savvy to embrace it, to consume it, right? So I recognized it and I discovered it, so to speak, when I moved to the service-oriented part of Cisco.
That is good to know, Murli. One question here: how comfortable was it to be working with customers and supporting them, particularly coming from an engineering or a developer mindset? The answer to this question and a lot more in the next episode. Don't miss that.
We thank Siddharth for the music and Anita for promoting the Software People Stories.
If you like this episode,
Please subscribe on your favorite podcast client.
And spread the word in your network.
if you'd like to share your story,
Contact us at podcasts@pm-powerconsulting.com.